Okay, our goal today, if you don't know who I am, my name is Mr. Warden. I primarily go by Mr. Warden because Mr. Warden's Workshop is my company. My company is primarily composed of a group of 10 people that use proprietary AI tools in order to build million-dollar ideas and execute million-dollar businesses, potentially billion-dollar businesses. Our first project that we tackled in a brief pilot that you may have seen on YouTube over the weekend was this. This is a fireman statue. The fireman statue was broken. Its head had come off after it collapsed in a falling bookshelf incident. As you can see, this is from when I was 3 years old. My grandmother made it for me, and it's one of the first things that inspired me, I think. You can actually see a picture of me seeing it for the first time. And now we must continue, because we have many things to discuss. I simply had some things on the table, and that is going to either distract me or empower me in the pursuit of what we're going to work on today. If you're wondering what these are, I showed these in the pilot video as well. These are gauge blocks. This is a machinist's tool that one would use if they needed to measure something very precisely, but so precisely that it's no longer feasible to directly measure something. We simply don't have tools well enough to measure that tight of precision. However, these are precisely ground, so we can comparatively assess precision. So, for example, if I needed a cut or a particular piece to be 0.144 in length, I can compare it to the size of this 0.144 gauge block, which has been precisely ground to be exactly 0.144 inches within a certain calibration. Within certain calibration, it tells you the calibration figures for each block. So if we're looking at 0.144, we see that there's a +8 deviation. +8 deviation refers to, doesn't say on here, but it's probably 8 microns. That would be the only thing that I would deem appropriate. +8 microns. Sure. Anywho, that's not why we're here. Some pickled asparagus should the need arise in the course of today's proceedings, just in case. So let's walk through the scope of today's project. Today's project is multifaceted and multi-purpose. As is tradition in Mr. Warden's Workshop, everything we do is multifaceted, everything we do is multi-purpose, and I wouldn't have it any other way. This is a 2000S Audio AMX7352. It's an audio mixer. I purchased it on Amazon some time ago. The USB port that allows you to connect the audio mixer to the computer in order to capture output or modify or modulate output. It's loose in there, and so as it's plugged in, as you're recording, it will just simultaneously, it will all of a sudden, spontaneously lose connection. It will spontaneously lose connection. So we're going to take it apart and see if we can fix it. We need a screwdriver. Screwdriver procured. Let us continue with the disassembly, for which we have not began. You're going to help me remember where these screws go, right? Okay, all of the switches on here are connected to the board, and they're all screwed in from the top, and they have knobs. So we're going to take all the knobs out and all the pieces out. Luckily, I think I have a tool for that right here. To help people learn about electronics, to help people learn about X, Y, Z. Oh, there's little washers here. Let's take those two. Lovely. Let us address our faulty component, which is our piece of junk in here. This USB drive, this USB port. That probably shouldn't do that. So if I'm going to isolate the USB port, we're looking at these 4 pins right here. As I move this, you can actually see the pins moving. I know you probably can't see that because this is a camera, but you get the idea. Those are the 4 pins of note. I might be able to just yank this out, so it actually might be beneficial for me not to yank it out, and instead just apply some fresh solder and see if that doesn't fix our looseness. Because all of the pins are loose. All of the pins do not want to cooperate on that particular port. Okay, so now we have to go find some solder and a soldering iron. We just need the smallest bit of adhesion. I just broke my chair. Now there's something else for us to fix now. I need to get a new chair. I need to get a workbench anyway. I'm tempted to try this. Will this break anything? Guess there's only one way to find out. Let's just try it. If it doesn't work, we can scrape it off and try again. Try something else. All I did was put a blob of super glue over the trouble area, see if it will calm it down. That may be too much, but we'll see. It's all a learning process anyway. Let's not fret about things we don't know. Let's simply use the opportunity to learn, as is tradition in Mr. Warden's workshop. What's the cure time on this? Alright, so let's take a look at the board a little bit. We'll zoom in here in the video. Let's talk about what's going on here on this board. So we have a little display, easy. We have 2 XLR inputs, which are for audio, which are for professional microphones, XLR inputs. We have audio inputs for a turntable or stereo. We have places for audio jacks, full-size audio jacks for things like guitars and amplifiers. We have all of the knobs that control all the different modifications that we can add to the sound on its way to the output. All of these inputs, well, not these two, all of these inputs go to the output. All of them, eventually. These 2 XLR cables also run through this whole series, this whole bank of switches right here, in order to modulate the sound that's coming in from these XLR inputs. And then that's eventually all going to go to the output, which is one of these. And as a matter of fact, it is these 2. This is main out. This is headphones. This is a slider connected to 4 capacitors that are simply modifying the amount of electricity that's able to get to the particular thing. This is like main volume. Okay, so it's as you move it, it's controlling how much sound actually makes it out of the output. And then we have some different controls to do different things that control sort of the whole system. And then we have USB power. We don't have any other way to power this thing except with USB, even if we wanted to. That might be something that we could attempt to modify, but I also don't think it's necessary. Let's try it out. Everybody hold on to your butts. Well, that kind of makes sense. I'm sure all of this is grounded to the chassis. I'm sure all of this is grounded to the case because it's made of metal. And let's kind of half put it back in the case, I suppose, to test it out. Our super glue did not work. We're going to have to go through and solder this anyway, so let's not put the case back on just quite yet, but let's do... I wish I had my multimeter. Nothing connects to the board, it only connects to the top. Oh crap. The one pin that was soldered in stayed in there. Shoot. What does that mean? See, there's another USB port back here for power, but I'm pretty certain that that says power only. I mean, it just says power. I don't know if that means anything. Alright, USB port. Let's think. What are our moves here? I don't know if I have extra USB ports lying around, although I'm sure I do. No dice. All of my sacrificial USB ports have either already been sacrificed or are in computers that are too good to take them apart. So what I'm going to do is ask my roommate and friend and business partner,
name and address withheld,
to bring me a busted computer or board that has a USB port on it, so I can harvest it, resolder it to this board, and go from there. Cut for now. Stay tuned.